Welcome to our lecture about IEC 61850. Today, we will have a look at the IEC 61850 standard and check what impact it has on the communication infrastructure for substations. IEC 61850 is a standard published by the International Electrotechnical Commission, and it aims primarily at substation automation. Whenever you have a tap-changing transformer or some switchgear or some sensors in a substation, you can connect it via IEC 61850. And then this piece of asset becomes available for remote control or remote diagnostics in the control room. Some people believe it's just a communication protocol, but that's not true. The standard contains much more. It also deals with functions. They're called objects and are described there. Another part of the standard is data types. How are measurement values and commands formatted and encoded? In a digital substation, you will find maybe a station bus that covers the entire substation and process buses that are for certain applications such as a transformer. Both are covered by the IEC 61850 standard. The standard itself contains many subchapters, including a number of specialized protocols. The first one of interest is called GOOS, Generic Object-Oriented Substation Event, and is a very fast protocol. It gives asynchronous messages that can be used as alarm messages or as commands. GOOS has a guaranteed maximum latencies of 4 milliseconds. Sample value, SV, is another such protocol. It's typically used for measurement data streams. You subscribe to certain data points, and these measurements are then streamed to you. Classical examples are voltage, magnitude, frequency, and so forth. MMS is a third protocol, Manufacturing Message Specification. It is used for configuring intelligent electronic devices, the IEDs. MMS is semantically rich. It is XML-based and can contain complex data. GOOS, however, is very simple, very fast. It is sent, and speed is all that counts. In the substation, you very likely also have a source of time. Maybe this is a GPS clock that receives time from satellites. Time can also come via fiber optic connections using time synchronization protocols such as IEEE 1588. Some substations have a little control room, a little shack with a human-machine interface to operate the substation. In most cases, however, the SCADA protocols are routed to the control center where all the switching actions and diagnostic processes can be performed centrally. The protocol stack of IEC 61850 shows the differences between MMS, GOOS, and sample values. If you look at the left side, MMS is a full stack. Physical and link layer are based on Ethernet. On top of that, you have IP, TCP, and the MMS protocol stack itself. GOOS and sample value, however, are much simpler. You just have Ethernet layer 1 and 2, and then you already have the application. This, for instance, means there is no routing, because routing is a layer 3 service. Since this is missing, GOOS and sample value messages are only locally available on their own home Ethernet segment. What is the impact of IEC 61850? The classical goal is to replace old SCADA and measurement wires with a clear and flexible OT infrastructure. Initially, every sensor and every actor had its own dedicated wire, sometimes even from and to the control room. Later, this was of course tunneled over packet switch networks, but only IEC 61850 has an entire well thought through architecture, both physically and semantically. Things get easier to build, to commission, to diagnose, and to repair, because the physical topology of the communication network is just much simpler. As already mentioned, the data model of IEC 61850 is also remarkable. Predecessors, such as Modbus or DNP3, have rather simple ways of encoding functions. So you saw register 30, 1, 3, and then you must check the manual of that device to find out what that means. Which data point is that? Is it the status of a circuit breaker or a temperature? And this is a great source of making mistakes in the commissioning phase. IEC 61850 is more human readable. Such a data point can be called relay 1/circuit breaker 1 health status value, so that you know it's the status value of health of that circuit breaker. This already helps during the commissioning to avoid mistakes. And it's cross-manufacturer, a so-called multi-vendor standard. All manufacturers use the same nomenclature. You can ideally replace a device from one vendor with another vendor's device, and the naming and the usage should stay the same. IEC 61850 is a powerful standard with many subchapters. Core of it is a set of protocols. Some have real-time capabilities, such as Goose. Others are more semantically rich, non-real-time protocols, such as MMS. What does it help with? It improves physical OT topologies inside the substation, and it makes it easier to commission, to diagnose, and to make multi-vendor installations possible.